We are covering lesson 4.4 on congruent triangles. The two objectives of this lesson are to use properties of congruent triangles and then to prove triangles are congruent using the definition of congruence. Let's start off by asking ourselves, what does it mean for two shapes to be congruent? So when we're thinking about shapes or figures, they have to be the same shape. We can't say a triangle is congruent to a square. And they have to be the same size. In past lessons, we've talked about congruent segments. We've talked about congruent angles as having the same measure. And in order for shapes to have the same measure, you'd say, we kind of have to focus in on each of those individual segments and angles. So in order for two shapes to be congruent, each or all of their corresponding angles and sides have to be congruent. And so that's where we get our definition of congruent triangles. Triangles are congruent if and only if all of their corresponding sides and corresponding angles are congruent. With triangles specifically, we know they have 3 sets of sides and 3 sets of angles. And so that just kind of gives us a goal of what we have to prove are congruent later on. Let's dig in a little bit with what the word corresponding means. It talks about parts of the figure that are related to each other. We might say corresponding parts are in the same relative position. So when I think about angle B here, angle B would correspond with what angle in the other triangle? It would correspond with angle E, because those are both between the 2 tallies and the 3 tallies. I know those are in the relatively same position, even though the triangles are not oriented exactly the same way. And so angle A would correspond with angle F. Side DE would correspond with side BC, and so on. So when we write a congruence statement for the triangles, the congruence statement, the order of the letters indicates to us which angles or segments correspond with each other. So if I name my first triangle, triangle BAC, I have to name the second triangle in a specific way that matches up corresponding parts. So if I name angle B first, angle B corresponds with angle E, so that needs to be the first letter in my other triangle. Next, I have named angle A, so I need to list F. And lastly, I've named C, which would be congruent to angle D. This is one possible triangle congruent statement. What if I switch the order around? What if I name this ACB? How would you need to name the second triangle in order to continue to match up those corresponding parts? We would need to name it triangle FDE. And so there's about 6 combinations of ways that we could write the triangle congruent statement between those 2 triangles. So we use that property of congruent statements, that corresponding segments and corresponding angles can be identified from the order of the letters, and we can apply that given any congruent statement. So here we have polygon LMNP is congruent to polygon EFGH. And my first reaction is that these are not triangles we're talking about. Even though a triangle is a polygon, I see 4 letters, so I know that this is some type of quadrilateral. But we can still look at the order of the letters and use that to write all the corresponding parts. So I'm going to highlight the first letters here. I know that angle L has to be congruent to angle E. I know angle M has to be congruent to angle F. Going on to the third letters, angle N has to be congruent to angle G. And angle P has to be congruent to angle H. Now this works for angles, it also works for sides. Since we name polygons by going around the vertices in consecutive order, I know side LM, segment LM, that's using the first and second letters, has to be congruent to side EF. MN has to be congruent to FG. Segment NP has to be congruent to segment GH. And that last one, you could name it PL or LP, has to be congruent to HE. Remember, we can name segments by their endpoints in any order. So here's all 4 sets of corresponding angles and all 4 sets of corresponding sides. We can also use that property of triangle congruence to match up those corresponding parts and write equations from that. So I'm given a triangle congruent statement. Triangle ABC is congruent to triangle DEF. I could go in and mark every single corresponding part that is congruent just based off of the directions. So I see side AB here. AB is the first 2 letters. I know that that corresponds and is congruent to DE. So I'm going to mark those sides are congruent. I also notice angle B is labeled here as 53. Angle B corresponds with, let's look at our triangle congruent statement to match up corresponding. It corresponds with angle E. And so this is where the triangle congruent statement is really helpful, because sometimes our eyes deceive us and we might think that B matches up with F. Those might look like they're the same measure, but they're not. So we have to trust the given information. Okay, so 2A, find the value of X. 2x minus 2 equals 6, because AB, sorry, not segment AB, the distance between A and B is equal to the distance between D and E. So solving that, we get x equals 4. Now they also ask us to find the measure of angle F. Angle F corresponds with angle C. So I know that those angles are congruent. So if I can find angle C, I can find angle F. I notice A is a right angle. Angle B is given, the measure is 53. So I can use the triangle sum theorem. $143. I guess we could have used the corollary as well and just done 53 plus x equals 90, but that's okay. Subtract 143 from both sides. Whoa, I'm blanking, 40, 37. So the measure of angle F is 37 degrees. We have explored the properties of congruent triangles and used those to solve problems. This last example here, we're going to try and prove triangles are congruent using the definition of congruent triangles. Remember, the definition of congruent triangles is that all sets of corresponding sides are congruent, all sets of corresponding angles are congruent. I'm going to set up my proof here. I'm going to start by reading the problem. They tell me F is the midpoint of segment SA and segment OI. So that's almost two pieces of information in one. They also give me segment SO is congruent to segment IA, and they tell me segment SO is parallel to segment IA. We're trying to prove the triangles are congruent. So I'm going to work one piece of good information at a time. F is the midpoint of SA and OI. That's given. So if I know F is the midpoint of this segment, SA, I know midpoint means it's dividing a segment into two congruent segments. So let's name those congruent segments. SF is congruent to FA. I use the definition of midpoint. So I've used the first part of the first given, the first part of the first given. Now let's use the second part. F is also the midpoint of OI. So F is also the exact middle of this other segment. So it's dividing that segment into two congruent segments. Let's name them. I know segment OF is congruent to segment FI. Also using definition of midpoint. So I've used up that first piece of given information. Let's go to the next given. Segment SO is congruent to segment IA. That's given. So let's go ahead and mark that on our picture. And there's nothing we really need to prove off of that. That's really useful actually, because that was our third set of sides. Now we've proven all three sets of sides are congruent. Now we need to find a way to prove all three sets of angles are congruent. So let's move on to our last piece of given information. Segment SO is parallel to segment IA. I'm going to use a different color here, and we need to mark that in our diagram. We mark parallel lines with arrows in the middle of the segment. So if I think about, let me get back to my pen, this set of parallel lines, I see two possible transversals here. If I think about segment OI as a transversal, we formed that Z shape. We have an angle pair formed here. Angle O is congruent to angle I. Those are alternate interior angles. Oops, I forgot to put given for number 5. So the alternate interior angle theorem says if the two lines are parallel, if two parallel lines are cut by a transversal, which we know those two lines are parallel, then alternate interior angles are congruent. We have another set here. If we look at, let's change gears. What if we think about SA as the transversal now? We actually have another set of alternate interior angles. So angle S is congruent to angle A. We're also using the alternate interior angle theorem. Now, in order to prove our third set of angles are congruent, there's a couple different ways you could think about it. You could use the third angles theorem, but looking at the picture, I'm going to use one of my freebies. These two angles formed by intersecting lines are vertical angles. Since F is a shared vertex, we do need to name those angles with 3 letters. So angle AFI is congruent to angle OFS. We're using the vertical angle congruence theorem. So we have proved that all 3 sets of sides are congruent. There's our statements. Those are all statements about sides being congruent. Then we also proved all 3 sets of angles were congruent. So that's the definition of congruence. The definition of triangle congruence says if all 3 sets of sides and all 3 sets of angles, if all 3 sets of corresponding sides and all 3 sets of corresponding angles are congruent, that means the triangles are congruent. So we can now say, we know for sure triangle SOF has to be congruent to triangle AIF.